Hello everyone and welcome back to Easy Dentistry. Today's topic for discussion is casting procedures for dental alloys. This is a very important topic. It is asked frequently in exams. But before proceeding with this topic, I request all of you to watch the lecture on dental casting investment materials which I have already uploaded. The link of which is provided in the description box. Please watch that lecture first. And before we begin, please subscribe to our channel and hit on the bell icon so that whenever we upload a new lecture, you get a notification of it. Also, share these lectures with all your friends and share knowledge. Give us your feedback by commenting below in the comment box. So, in this lecture, we will be studying the steps in casting, what are the various defects in casting, and defective casting and its causes. First, let us study what is the lost wax pattern technique. As the name suggests, the wax pattern is lost in this technique, so it is called as the lost wax pattern technique. Let us see how it is lost. Suppose this is a die with a prepared wax pattern on it, which is shown in red color. Now, this wax pattern is connected to a sprue. And then this wax pattern with the sprue, which you can see that a vertical line here showing is the sprue. This is the sprue. So this wax pattern along with the sprue is invested in the proper investment material. After that, a burnout is carried out. That is, all the wax present in the wax pattern and the sprue is burnt out. Then after the burnt out, there is an empty space which is present inside this investment material, and now this empty space is filled up with an appropriate alloy, forming the casting. So this entire procedure is called as casting procedure. In this procedure, the wax pattern which was first constructed on the die is lost, so it is called as the lost wax pattern technique. Now, we will be studying in detail this entire procedure of casting. First, the steps in casting. There are around 14 steps in casting. The first step is to preparation of the tooth on which the prosthesis is to be fabricated. First, the tooth is prepared, then a proper impression of the tooth is taken. Then there is die preparation from the impression. Then a wax pattern is formed on the die. The wax pattern is connected to the sprue former. Then there is a lining of the casting ring. Then there is investing of the wax pattern with the help of proper investment material. And then the next step is wax elimination and burnout. Then the casting with appropriate alloy is done. The 10th step is quenching of the alloy. Then 11th is the recovery of the casting. Then the sandblasting, pickling, and finally the polishing of the casting is done. First, let us see the tooth preparation. Suppose this is a picture of the tooth on which the prosthesis is to be constructed, or the casting is to be constructed. So this tooth is prepared appropriately to receive the casting. Second step is taking an impression of the prepared tooth. So with the help of appropriate impression material, an impression is made from the prepared tooth, which you can see here. Next step is die preparation. What is a die? Die is a working replica of a single tooth or multiple teeth on which inlays, crowns or bridges are to be made. So a die stone is poured into the impression taken and a die is formed. These are the dies which are formed from the prepared tooth. Also on the die, a dye spacer coating is applied. As you can see here, silver colored is the dye spacer coating. This is called as a dye. Now the next step is preparation of wax pattern on the dye. Type 2 inlay wax is used to prepare the wax pattern. As you can see here in this diagram, these are the prepared wax pattern on the dyes. The next step is the sprue former. Now, this is a diagrammatic representation of the casting ring. This is the casting ring, and this is the wax pattern. This one is the wax pattern in the shape of the tooth. Now, sprue is nothing but a sort of a pipeline which is attached to this wax pattern. This sprue has many roles to play. Let us study this sprue in detail. So, coming to the thickness of the sprue former, the thickness of the sprue should be in proportion to the wax pattern. The length of the sprue should be 3/8 inch to ½ inch. The wax pattern should be adjusted such that it is not more than 1/4 inch from the top of the ring. Now, the classification of the sprue. The types of sprue may be metallic or non-metallic. The metallic sprue may be made up of steel, brass, while the non-metallic sprues are made up of plastic, resins and waxes. Depending upon the shape, the sprue may be either solid or hollow with a round or a triangular shape. Now, the uses of the sprue former. The sprue former is used to form a mount for the wax pattern. Then the second use is to create a channel for wax elimination. When the wax pattern is heated, the wax is eliminated from the mold through this sprue. Now, the sprue also acts as a channel for the inflow of the molten metal. After the wax is eliminated through the sprue, the molten metal is forced inside the mold through this sprue channel. So, it is used in this. And then the sprue also helps to compensate for the shrinkage during solidification. Now, the next is the casting ring liner. This is a diagrammatic representation. This is the casting ring, and you can see here on the inner surface of the casting ring, this white color is the ring liner. So this ring liner is of various types, the asbestos type and the non-asbestos type. The asbestos type is not used because it is carcinogenic, while the non-asbestos type of ring liner may be made up of cellulose or ceramic aluminous silicate or a combination of these two. Now, what are the functions of the ring liner? The ring liner helps in mold expansion. Also, it is a thermal insulator, so it reduces the heat loss. Also, it acts as a separator between the investment and the ring. Now, the seventh step of casting is investing. These are the steps of investing. First, a wetting agent is applied to the wax pattern. Then, the wax pattern is placed at the center of the casting ring. Then, the ring is placed in the crucible former, taking care that there is uniform space around the wax pattern. Then, the mixing of the investment material is done using the proper water powder ratio. After that, a small amount of investment material is applied with the help of a brush on the wax pattern. Then, the ring is filled with the remaining wax pattern. It is then allowed to set for an hour. The next step is wax elimination and burnout. Now, in the process of burnout, there is total elimination of the wax from the mold and thermal expansion is achieved. The burnout should be done when the mold is still wet. It is done gradually by heating the mold up to 400 degrees Celsius in 20 minutes, and then it is maintained at this 400 degrees Celsius for the next 30 minutes. After that, the mold is heated further up to 700 degrees Celsius in the next 30 minutes, and then it is maintained at this 700 degrees Celsius for the next 30 minutes. If this heating is carried out very rapidly, there may be steam formation in the mold causing flakiness of the mold walls. And cracks may also occur in the investment, and in extreme cases, explosion may occur. The next step is casting. Now, the casting should be completed as soon as the ring is ready. If the ring cools down, the investment cracks. There are two types of casting machines which are used for casting. The one which use centrifugal force and one which use the air pressure. Now, this is the machine which is which uses the centrifugal force for casting. The advantages of this machine is that it has a very simple design and it is suitable for big as well as small casting. While this is a casting machine which uses air pressure for casting, it uses compressed air, but due to complications, this is suitable only for small castings. Now, various metals are melted together. There are various modes of melting these metals. Two of them are using a blowtorch, or second by electrical resistance or induction. Let us study the blowtorch in detail. The fuel used in the blowtorch is either natural or artificial gas and air with the combination of oxygen and acetylene gas. Remember this composition of the fuel of the blowtorch. Now, the flame of the blowtorch has 4 zones. This is a very important question which is asked in exam, the 4 zones of a flame. The 4 zones of the flame are: first, the mixing zone. Starting from the inwards, first is the mixing zone. The mixing zone is a combination of air and gas. It is dark in color. You can see here I have shown in black color. It is dark in color and no heat is present in the mixing zone. Then surrounding the mixing zone is the combustion zone. Now this combustion zone is green in color and it is a zone of partial combustion and it is oxidizing in nature. Surrounding the combustion zone is the reducing zone. Now this reducing zone is the proper zone and it is the hottest part of the flame. The fusion of the casting alloys should be done using this reducing zone. And then the outermost zone of the flame is called as oxidizing zone. This outermost zone is not used for fusion. It is a combination of gas and air. So, it causes oxidization of the metals. So, it is not used for melting the metals. But the reducing zone is used for melting the alloys. Now, the next step is quenching. In quenching, the casting ring containing the alloy is immersed in water and it is left in water. This quenching of the alloy of the casting ring causes fragmentation of the investment material and easy removal. Then the recovery of the casting is done. The investment is removed after quenching and casting is recovered. The next step is sandblasting. The recovered casting is cleaned up using a sandblasting machine. And then is the pickling. Pickling is done with the help of 50% hydrochloric acid. This 50% hydrochloric acid is heated, but taking care that it is not boiled. And this hydrochloric acid, which is warm, is used for the removal of surface oxides. Then the final step is polishing. If all the other steps are carried out meticulously, minimum polishing is required for the casting. Now, let us study what are the various defects in casting. The most commonly found defects in casting are dimensional inaccuracy, rough surface, and porosity. Casting may be contaminated due to two reasons. First, there may be oxidation of the casting, which may be caused by overheating of alloy, or if you use the oxidizing zone of the flame to melt the alloys, or if you fail to use the flux. And contamination may also occur due to release of sulfur compounds. If you heat the casting ring to a very high temperature, there is breakdown of the investment material, which releases sulfur compounds and cause contamination of the casting. Now, the defective casting and its causes. Very important question, very important question, which is asked in your exams. Long answer, short answer, MCQs, Viva, PG entrance, and everywhere. So the defective casting are classified into 4 types: distortion, surface roughness, porosity, and incomplete casting. Now, the distortion of the wax pattern may occur due to 2 reasons. First, if the investment hardens due to hygroscopic or thermal expansion, and if you manipulate with the wax pattern, there is release of stresses causing distortion. The distortion is minimized by either manipulation of wax at high temperature and investing the wax pattern within 1 hour, or if storage is necessary, store it in a refrigerator. Second is the surface roughness. There are various reasons for causing surface roughness on the casting. Let us study each in detail. First is the presence of air bubbles. If there are presence of air bubbles on the wax pattern, if you can see here, air bubbles are present on the wax pattern, and if you cast this wax pattern, there is formation of nodules on the casting. See, you can see here, there are formation of these nodules on this casting. So, air bubbles causes roughness of this casting surface. Now, how it is avoided? The air bubbles can be avoided by proper mixing of the investment, vibrating the mix, and using a wetting agent. Now, the second reason for surface roughness is very rapid heating. Rapid heating causes cracks in the investment material, and this causes fins on the casting. To avoid these effects, heating of the ring should be done gradually up to 700 degrees Celsius in 1 hour. The next cause of surface roughness is the increased water powder ratio used and increased particle size used. Both of these causes rough casting. So, proper water powder ratio and proper size of the particles is recommended. Prolonged heating of the casting ring causes disintegration of the walls of the mold cavity, and this disintegration of the walls causes the surface roughness on the casting. If the casting temperature is very high, or there is overheating of old alloys, there is disintegration of the investment causing roughness. Then if the casting pressure is too high or too low, there is surface roughness on the casting. This is avoided by using a uniform casting pressure of 15 lb per square inch of air. Then the next reason for surface roughness is composition of investment. Proportion of quartz and binder influences the surface texture of the casting. Coarse silica causes coarse casting and surface roughness. Presence of any foreign bodies in the mold causes sharp, well-defined deficiencies. Inclusion of flux also causes big concavities on the casting. Then let us study in detail a very important topic, that is the porosities which occur during the casting. Very important question. Get thorough with it. Watch this part very carefully. There are various types of porosities. First is the presence of irregularly shaped voids on the casting. The reason of which is inclusion of particles of investment material. And to avoid this, the mold is heated upside down so that the loose particles of investment material falls off. Second is the spherical voids. Spherical voids occur due to occlusion of gases in the molten alloys, and these can be avoided by avoiding overheating of the alloys. Then third is the shrink spot porosity or pitted casting. Now what is this shrink spot porosity? These are irregular voids, and why do they occur? It occurs due to shrinkage of the molten alloy on cooling. Now, if this is the casting ring containing this the burnt out space or the mold, and this is the sprue. If this sprue is very thin, what happens is that when metal is passed from this screw, it occupies first the outer surface of the mold. And this outer surface of the mold, it becomes solidified first and leaving back a internal core of still molten alloy. As the metal cools down, this layer of solidified alloy on the periphery, it increases, but the core is still soft. Now in this case, if the sprue used is very thin, the metal present inside the sprue itself undergoes solidification, while the bulkier space is still partially molten. The core is still molten. This is the core which is still molten. Now, as time elapses, this core also undergoes solidification. And because of the solidification, we have seen there is always some amount of shrinkage which occurs. Now, this shrinkage causes more space for the molten metal to occupy. There is shrinkage of this casting and more metal is required to fill this space which is caused due to shrinkage. You can see here the white, this is the space which is formed due to this casting shrinkage. Now we have seen the thin sprue and the metal is already solidified in the sprue. So no more molten metal can be provided through the sprue to fill in this space which is formed during shrinkage. So this leads to the formation of voids, and this is called as the shrink spot porosity, which is caused due to shrinkage. How to avoid this? The sprue should be thicker than the casting, and also there is a flaring of the sprue at the where it is attached to the wax pattern. Now this shrink spot porosity mostly occurs at the junction of the sprue and the wax pattern. Now the next is the back pressure porosity. The back pressure porosity is formed when the air is unable to escape from the mold cavity. Suppose this is a mold cavity and a molten metal is inserted into this mold cavity. The air which is present inside this mold cavity then should leave this mold cavity and it should be occupied by the molten metal. If this air does not escape from the mold cavity, it may result into porosity called as the back pressure porosity. This can be avoided by inserting the melted alloys with appropriate casting forces, using of porous investment material, and placing the wax pattern 8 to 10 mm away from the end of the ring. If this thickness is more than 8 to 10 mm, escape of air is not possible, and also vents should be provided in large castings to allow air escape. Then the next type of defect is the small casting. Small casting mostly occur if the mold do not expand sufficiently to compensate for the casting shrinkage. Also, there is a defect called as black casting, which occurs due to two reasons. First reason, if overheating of the investment is done above 1350 degrees Fahrenheit, there is decomposition of the investment. There is liberation of sulfur compounds from the investment. These sulfur compounds, they combine with the alloys and form a sulfide film on the alloys, resulting into black color of the casting. The second reason is that if the wax is eliminated by a low prolonged heating, that is low temperature heat is applied while eliminating the wax, there is incomplete elimination of the wax and carbonized wax residues are left back on the casting, giving it a black color. Another type of defect is too bright or shiny casting with rounded margins. If this is a casting ring and this is the mold, if there are certain wax residues present in the mold, this wax, it reacts with the oxygen in the air, forming carbon monoxide gas, and this carbon monoxide gas is a reducing agent. It prevents oxidation of the alloy, giving the alloy a very bright and shiny surface. Also, with this shiny surface, you can also find the back pressure kind of porosity in this case. The next is the suck back porosity or the gas blow holes. If there are wax residues in the pattern chamber, they give off large volume of gas as the molten metal enters into the mold cavity. They give off large amount of gas and these appear as blowholes on the casting. And this is called as suck back porosity. In this, we can see this is a suck back porosity which has occurred. This can be avoided by using a sprue hole facing downward so that the wax may run down and there are no residual wax in the wax chamber. Then the next type of defect is contamination. Contamination may occur due to oxidation when the metals are overheated. If there is melting of the metal using oxidizing zone. Next, there is a failure to use flux, or if there is overheating above 1350 degrees Fahrenheit. The next type of defect is the incomplete casting, which may occur due to insufficient alloy used, or if the alloy is unable to enter into thinner parts of the wax pattern, the thinner parts of the mold. Then if the alloy is not heated to its casting temperature, if there is early solidification of alloy, then incomplete casting may also because of sprue blocked with foreign bodies, or back pressure which is caused by gas, or if low casting pressure is used and if the alloy is not sufficiently molten. Now here we complete with the entire topic on the casting procedures. Now let us solve a small quiz. Question number 1 is for fusion of alloys, which zone of flame should be used? Question number 2, pickling of the casting is done using what? Question number 3, if the sprue is thinner than the casting, the resultant porosity is called as what? Then the last question, porosity caused due to inability of the air to escape from the casting mold is known as what? So here then we declare with the topic of casting procedures completed. The next lecture will be on direct filling gold. If you don't want to miss direct filling gold, please subscribe to our channel right now. Before closing this lecture, please subscribe to our channel. Also give up a thumbs up if you like our lecture. Share with all your friends, and do let us know your feedback. That's all for now. Happy studying.